Anybody that filters in can catch up. Raise your hand if you're directly responsible for the maintenance or operation of a database today. Great, you're in the right spot. The rest of you guys, you're welcome to stay. I'm not sure how relevant it's going to be for you. We will be talking about managing a healthy Couchbase server deployment today. And just jump right into it. As an operator, you're probably going to be tasked with these 4 items primarily. First is sizing of an environment, so determining how many resources you need and what that translates to in terms of server resources. You'll be tasked with installing, configuring, and tuning the service, setting up monitoring, and ultimately using that monitoring in order to determine server health and then take both proactive and reactive steps in order to maintain it. Now, all of these apply to essentially every service. They also still apply to Couchbase. Unfortunately, with only 30 minutes today, I'm not going to be able to go through all of them, give them all their due justice. So I'll give you some resources you can follow up on. So sizing, go to our docs page, take a trip back to 1999 AOL, and we'll do keywords instead of giving you URLs. So go to couchbase.com, search for sizing. You'll find our resources there on sizing. Fantastic presentation by Perry Krug from Connect 2015. If you just search for sizing on the connect15.couchbase.com site, you'll find that. Installation on Couchbase is very straightforward. What you want to know is how to tune Couchbase. And I gave a fantastic master's level presentation on that and at our Connect 15 conference. Just search for tuning on there, you'll find it. And finally, maintenance. It's far too varied of a topic to boil it down to 30 minutes. So go to couchbase.com, search for admin troubleshooting, and you'll get a good list of some first, primary level things you should try to resolve issues. What we're going to be concentrating on here is monitoring. So how to set it up and what matters, and a bit beyond that, what are some of the first steps you should take should you encounter issues with any of these particular metrics. Please make this interactive. If anyone has any questions, you have any comments, shout them out. Worst thing in the world would be me just pontificating on monitoring for 30 minutes. First question on monitoring is how do you get the stats? Couchbase gives you 4 different ways. 3 ways if you want to integrate with an existing monitoring solution. First and foremost, we have our REST API. That is our canonical API. All of the rest of the APIs are really just a subset of that data. We provide you command line access via the CBstats tool. We do output our stats to a file every minute, which you can grab. And of course, we have a web UI that ships with the product that has built-in trending and alerting functionality, albeit limited. So stats via REST, your request to the REST endpoint will look something like this. You're going to give it an IP address, specify a bucket that you want to fetch stats for. Those stats will be specific to the server that you're requesting the stats from. So to get a full view of your cluster, you will need to fetch those stats from all of the nodes in the cluster. Because REST is the canonical API, all of the components represented within Couchbase, namely the data service and the admin service, those metrics will be returned to you from this endpoint, and it will be formatted JSON, so you can parse it fairly easily. Most monitoring systems are going to essentially cron your stats pool for once a minute, right? So once a minute, you'll go fetch some stats, and that's what you'll put into your monitoring system. That's going to give you just minutely granularity on your stats. Couchbase does capture stats every second, though. And so by default, what you're going to be returned in this REST call is going to be 60 secondly samples of your data. So you can get very high resolution of your stats in your monitoring system. We do support additional options, including Zoom, which says, give me minutely stats, hourly, daily, up to yearly. You can set a zoom level for that, and then the number of metrics that are returned will vary depending on the zoom that you set. We also have T-stamp option, which says, give me all the stats since this date. So you know when the last time you requested stats, you can provide that timestamp and get everything that you've missed since then.
Question.
Sure.
How much overhead is on that stats call? If I hit that every minute, is that going to add overhead to my system, or
No.
put locks in place or something?
So it's going against our Erlang cluster manager. requests of that aren't cheap. It's certainly not as cheap as going against our CRUD interface. As long as we're talking, not more than a few dozen per second, you're fine. So minutely fetches are perfectly fine.
That's the
No
same
issues.
JSON that drives the GUI, right?
It is.
The web console.
Yeah. We also offer the same stats or similar stats via command line. So there is a process or a command that ships with Couchbase. It's under opt Couchbase bin by default. It's called CBstats and has a bunch of different options that you can run against. From a monitoring standpoint, what you really want is the all. At last count, we have something like 303 stats returned from that. And out of that list, you can parse out the ones that you're interested in. And I'll give you the ones that are interesting here in a bit. These are going to be specific to EP Engine. EP Engine is essentially our data manager. NS Server is our data or cluster manager. So two different components, EP Engine being the C-based component, shows up as memcached as the process name. NS Server is the Beam process. That's the Erlang that's doing all the cluster management. CBstats only fetches the memcached stats, but for our purposes of monitoring, that's going to contain something like 99% of what we're actually after. So if you do have an agent that can only collect stats from the command line, this would be the one to use. These are returned by default in key value format, just like what's presented on the screen, which makes it very easy to parse from typical traditional monitoring systems. If you have a parser that would prefer something like JSON, you do have an option to output these stats as JSON. And finally, the option of last resort. Every minute we are checkpointing stats to disk. So there's a log file under the logs directory called stats.log. Every minute we're going to refresh that. That will be a dump of both the NS server and the EP Engine stats. So both cluster manager and data manager stats will end up there. But the format isn't pretty. This is a dump for our own internal use that you can consume. So half of it's going to be in Erlang tuple format, half of it's going to be in this key value format that you would get from CBstats output. So if you end up needing to use this file because for some reason you can't talk to REST and you can't run a command from an agent, you will need to create a custom parser in order to read this data back out. Finally, we do present stats via our web UI. I'll just take you briefly through what's available via the web UI. So first, we present stats on a per bucket basis. You can also get stats on a per server basis. By default, this bucket data will be data across all of the servers in the cluster for a given bucket, but you can break that down per server per bucket if you like. We are presenting, so out of those 303 stats you can get from CBstats, we're rolling those up to about 120 stats that are meaningful to present. The rest of the stats are more debugging level that you probably wouldn't need from a display like this. You can view them at different levels of aggregation. So by default, it'll be displaying minutely, but you can take it all the way up to yearly. Keep in mind that Couchbase, we're providing this as an aid to you operationally. So if something has occurred and you need to find out what that is or what caused it, you would jump into the system, and this will give you a pretty decent idea for recently what's been up with your cluster. But we aren't intending for this to be a long-term monitoring solution for you. So these stats are heavily downsampled over time. So by the time you get to the yearly stats, you're going to be seeing just the very peaks of any of the actual data that had occurred there. You are able, on a per metric basis, to break that down into individual servers. So you can see what each server did to contributed to that aggregate metric. And finally, if you hover over one of the metrics in our UI, you'll get the specific API level metrics that we use to calculate that graph. Not all of them are one for one. Some of them combine multiple metrics and provide something more meaningful to you. We also provide some built-in alerting. This is all very basic alerting, and it's all about letting you know that something bad has already happened. By the time you get an alert from Couchbase for one of these, something has already failed. You need to go and correct it. at the end of the day, this isn't what you want out of a monitoring system. What you want out of a monitoring system is something that will trend your data with full fidelity for a very long period, and also be able to provide you proactive alerts based off thresholds that make sense to your environment. And because of that, I highly recommend that you have an external monitoring system that you integrate all of these stats into. We have off-the-shelf integrations with a number of different utilities, but really any monitoring system that supports a local agent or can talk REST, you can integrate with Couchbase. All right, pretty dry stuff. Moving on to the metrics that matter. So from a Couchbase point of view, these are going to be the metrics that are really key for you to monitor, and all of these will be available online, so don't feel the need to take notes on each one right now. The first is going to be your cache miss ratio. This defines how many of the fetches from Couchbase had to go to disk in order to satisfy the request. So essentially the number of requests that weren't able to be satisfied directly out of memory. For most use cases, because Couchbase is typically deployed in order to be a very fast data access method, we want most of these requests coming out of memory. So typically something less than 1% is ideal, but there are cases where you might have explicitly sized your cluster for normally cost reasons to be able to accept a certain percentage of your reads coming from disk. You want this cache miss ratio to be in line with what the expectation is. The next metric is going to be memory use. So when you create a bucket in Couchbase, you're going to define a certain amount of memory, a quota, that bucket can consume. Couchbase will try to use all of that memory by default. So as you access data, we're going to be reading that data into memory. And then after a certain point, you might have consumed all of that memory, or all of the memory that we want you to use. And that limit's called a high water mark. So we'll continue reading data in until we hit that high water mark. Usually that's 85% of your quota. And then we'll start ejecting data out of memory until we hit a low water mark in order to make sure that you're not overrunning that memory quota. This process of ejecting data out isn't free. It's pretty lightweight. All we're doing is we're validating that the data we want to eject exists on disk, and then we will eject it from memory and then free up the in-memory structures. It's lightweight, but it isn't free. So what we don't want to happen is for you to be continually hitting this high water mark and then continually ejecting data from memory. This should be a relatively infrequent occurrence. If you are hitting this relatively frequently, you want to increase the overall memory that you have available. Either that means allocating more quota to the bucket if you have free memory on the system to do so, or scaling the cluster, adding more nodes in order to give yourself more total memory that you can allocate. The third for memory is the temp OOM parameter. So there are a few cases in Couchbase where we will start sending essentially back-off messages to your application. One would be if your total memory used goes to above 90%, or if the disk write queue on any of the nodes exceeds 1 million objects. We'll start sending these temp OOM messages saying, I don't have enough memory to satisfy your write request. Take a beat and try again in a few seconds. General, this is a soft error, so it's not saying that we weren't able to do it. We're saying please back off and retry. There is a separate metric for hard OOMs, which you will want to track, but you'll start seeing these first. So from a monitoring standpoint, these are the ones that you'll probably want to track. The goal is to have none of these. So the goal is to always have more than 10% of your memory free, always have your disk write queues less than 1 million objects per server. If you see these, it means that your application is necessarily going to be seeing higher write latencies than you would otherwise expect. Simple solution is either to decrease your write rate, which is going to mean you're going to need to remodel your data model, or simply scale the cluster in order to give yourself either more disk I/O, if that's the bottleneck, or give yourself more memory if you just need more memory to accommodate your write rate. Disk. So number one metric, and this is going to be the number one metric across Couchbase in general from what I've seen, is the disk write queue. Number one bottleneck I've observed is that your disk is too slow to accommodate the write rate for Couchbase. Goal for this is to keep it under 1 million objects in queue. Again, that's the point at which your temp OOM will be fired. Really, you're going to want to set this to whatever makes sense for your particular environment. If your environment isn't expecting to have 1 million items in queued because you're not expecting that sort of write rate, you'll want to figure out what your baseline is and set this to, say, 20% above that. This disk write queue, maybe you should back up. What that represents are the number of writes that are outstanding, that the writes have made it to memory, but they haven't yet been persisted to disk. So we'll take a write in memory, we'll acknowledge the write to your application, and then asynchronously we are writing this data to disk. While that data exists in memory but not yet on disk, it'll appear here in the disk write queue as an object, yes.
For the disk write queue, I think there is also a parameter which is the time-based number of seconds. So what is the ideal number of the number of seconds in terms of if you want to put the monitoring on disk write queue in terms of number of second wait times?
Sure, you're referring to the average age metric, right?
Yeah.
So we do report the average amount of time that a given object has been in queued before it makes its way to disk. There isn't an ideal number. It's really dependent on your business and how much exposure you can sustain. Typically, customers are looking at maybe 10 to 15 milliseconds being the high end of what's considered acceptable from between when you receive a write to when it's persisted. Other customers, they require much less. It's really up to you as to what your requirements are. You can monitor it. If you set some sort of limit for yourself, you can alert on it, and then you can act on it. Typically, that means just scaling the cluster out so that you have less congested I/O, or it could mean changing your storage hardware. So if you're currently running against a SAN, giving yourself local storage, and that'll increase the amount of I/O and therefore lower that queue time. The other metric for disk that's really going to matter is fragmentation. There are 2 metrics for this. We have metrics for both docs, which is the on-disk data storage fragmentation, and for views. Couchbase is on disk an append-only system. So as you write into Couchbase, rather than replacing that object in place wherever it exists on the on-disk file, we're just going to be writing a new copy of that data and appending it onto the end of the file and then moving our pointers to say this is now the current revision of that particular document. This is very fast, allows us to really optimize our disk writes by serializing as many of those writes as possible, limiting the random I/O. The trade-off there is that we will be generating garbage as you overwrite objects, as you do updates to existing objects. Those new objects will be appended at the end. Those old objects are tombstoned, which means they still exist. We just mark them for eventual deletion. This shows up under the fragmentation parameter as a certain percentage of the overall data set that is now considered dead bytes. From a systems point of view, this just means that over time you would expect your on-disk storage to grow, and then as a compaction event occurs, to shrink back down. In general, when it comes to sizing, we recommend a multiplier of about 3x. So if you expect to have 100 gigs of total storage on disk, you want to allocate something like 300 gigs of storage so that you can accommodate these, the sinusoidal wave of garbage and then garbage collection. But we, in general, want to limit the number of compaction runs to something relatively low so that we aren't taking up this disk I/O frequently by rewriting your files without the garbage in place. By default, these compaction runs will occur once you've reached a 30% dead bytes threshold. And for that reason, the goal in general when monitoring fragmentation is to keep it under 30%, so something in the 20x range. Question?
You just answered.
Great.
So that I'm clear, this might be a little elementary, but can you just briefly discuss the relationship between how how Couchbase uses RAM and, not versus, but the relationship between how Couchbase puts things in RAM and how it saves things in storage?
Sure.
Based on what you just said.
Yeah. So when you write a given object into Couchbase, it's first going to be written into RAM. Within RAM, all of the objects are stored in essentially a big hash table, right? So you write a piece of data into memory on Couchbase, say it's an update. We'll just replace that object in memory within the hash table where it happens to live, no big deal. We then queue that write for eventual persistence to disk. When we write it on disk, we aren't storing it as a hash table. We're storing it as technically a B superstar tree. Think of it as just a big B plus tree that is optimized for append-only additions. So on disk, we're going to take that entire object that you just overwrote, and we're going to put a whole new copy of it onto the end of the on-disk file that represents the shard that particular piece of data belongs to. And then over time, as you generate more and more copies of this data because you have multiple revisions that you've been writing, eventually you'll hit a threshold, fragmentation threshold of 30%. Couchbase will kick off a compaction event, which will just rescan that entire on-disk structure and then rewrite it without the old copies of the data. Moving on, is everyone familiar with DCP and XDCR? A couple folks. For those that aren't, DCP stands for Database Change Protocol. It is the protocol that we use internally for routing any changed data between all the services that would need to know about it. So when you write a piece of data into Couchbase on the active node, you're going to have a number of other services that are subscribing to essentially its change feed that is represented within TCP. So these other services might be replica vbuckets that are trying to keep replicas copies of the data on other nodes. This might be indexers, which want to be notified whenever a new piece of data is written to Couchbase. It might be XDCR, which is cross data center replication. It wants to know when a new piece of data is there so it can replicate it across the WAN. It could be other integrations with tools like Solar or Elasticsearch, Storm, those sorts of technologies that integrate with this DCP protocol. They'll all be notified as soon as a given object appears in the system. There are some metrics that are important to keep an eye on in order to make sure that this whole distribution of your data remains healthy. From a DCP point of view, you want to take a look at the items remaining stat. There will actually be a number of these, one for key value, one for indexing, one for XDCR, and then there's an other, which is really just anything that isn't one of those services like an Elasticsearch or Solar, what have you, that's consuming us. There will be some queues associated there. In general, you want this to be a very low number. For, say, the KV, from the KV standpoint, this number represents the total number of objects that have been written into a node that haven't yet had a replica created for them. And if you're relying on replicas for durability, which in Couchbase you most likely are, that represents the total exposure to data loss if that active node were to fail. So you want this to be a very low number. Obviously, it's going to be very much workload dependent as to how low this number gets. We are bound by physics as to how fast we can move data from node to node, but this should be in the range of tens to hundreds of objects at any given time. Beyond that, you're probably network congested, and you need to scale the number of nodes in order to give yourself more network bandwidth.
Are these cluster-wide or per server?
These are per server. Actually, you can look at it two different ways. So depending on where you're looking at it in the web UI, if you're looking at it from the buckets panel, it'll be across all servers for that bucket. If you're looking at it from the nodes panel, it'll be specific to that node across all buckets.
When would you be looking at the per bucket across all servers?
There are times when you're running a multi-tenant environment to where you want to be able to report back to users that for your use case, you are consuming this % of resources. You might look at it that way. From a monitoring standpoint, we don't care. We really just want to pay attention to the per node metrics.
Oh, per bucket, not okay.
Per bucket is for multi-tenancy, and reporting for monitoring, you want to pay attention to per server. The other metric, which is related to this, but it's specific to XDCR, is mutations. It has the same connotation, but instead of internal cluster replication, we're talking about replication between clusters at this point. So there's a mutations metric that's going to be exposed for your outbound XDCR section that's created after you create an XDCR connection. This stat just represents the number of mutations that haven't yet been replicated across the WAN to the other cluster, and represents your exposure to where if you were to lose a data center, how many of your mutations, how many of your writes would be missed by that other cluster. Cool. Finally, and this one's pretty basic, but it's also pretty important, are Epoch Accounts. So in Couchbase, you write a given piece of data into a node. That node isn't going to be responsible necessarily for all of your data. It's going to be responsible for a subset. Each of the buckets you configure in Couchbase is going to be automatically sharded across 1,024 active vBuckets. vBuckets is just our name for a shard. And then 1,024 times the number of replicas you've created, replica vBuckets that are going to be distributed across other nodes in the cluster. It's very important to monitor that you have all the vBuckets that you expect to have active. And active here has two connotations. For active vBuckets, these are the vBuckets that will be read by default when you try to fetch a given object out of Couchbase. There should always be 1,024 times the number of buckets that you have. You should always have that number of active vBuckets across all the nodes in your cluster. For replicas, it's 1,024 times the total replicas across all the buckets in your cluster. That should be the total count that you have. We would expect that in a failure scenario, that your active vBuckets will go down by whatever percentage of active vBuckets was hosted by the node that failed. But we should expect that that will go back up to 1,024 as soon as a failover has occurred. What failover does is just promote replica vBuckets to active. It's just flipping a bit. At that point, we'll see 1,024 active vBuckets, but we'll see some subset of missing replica vBuckets at that point, right? Because they were just converted to active. At that point, you would need to, if you got an alert that you were missing some replica vBuckets, it would be an indication to you that you need to run a rebalance in order to recreate those missing vBuckets. If for any reason you have missing active vBuckets, but you aren't in a failure scenario, it means that the startup for Couchbase has errored for some reason. Either you have some on-disk corruption and I can't load those vBucket files, or something else is stalled during the startup process to where I don't have all of my active data accessible. And this is very bad because it means 1 over however many vBuckets you've lost is the number of requests are going to fail from your application side. That percentage of your data set's offline. Any questions on key Couchbase metrics before I move on to the system metrics that matter?
Are you going to cover new metrics for index nodes?
Frankly, those haven't been defined yet as to what really matters. Yeah. We have a bunch of metrics that exist. If you take a look at the REST API, if you were to run that REST query that I showed earlier, you'll get indexer methods or indexer stats returned. Really, it's just a matter of today whether or not the indexer is running and what the fragmentation level is. Those are the ones that I know that would matter. Beyond that, we don't have very many production installs to be able to say what we should be looking for yet. If you come to this next year, I'm sure we'll have a more complete list. Any other questions on Couchbase metrics? Okay.
Even without loading every vBucket, how come Couchbase comes up? Like, it knows there is an issue with Couchbase and with the server sound. Like, say, if it just loads 1,000 vBuckets, it's missing 24 or on.
The question is, why does it continue to start up?
Yeah, because if it starts up and it joins the cluster, it's serving some data and entering out some kind queries.
So the node would have already been joined to the cluster in order for it to have ownership of any data when it starts up. So it would have already been part of the cluster. The reason why we allow it to start up and start serving data even though it doesn't have the full data set available is because our goal is to give you as much access to as much data as we can at a given point. It's up to you to understand that there might be some subset that's missing, and that's why monitoring is important.
There is a replica to replace that data. Even if this node is not up, there is another replica that has full data set. If this node is not up, that replica might have been serving those queries.
And they still can. We do have read from replica available. So if you have an active vBucket that doesn't come online, doing a fetch from that vBucket will return a timeout. And best practice is to catch those timeouts and issue a read from replica as a result. So you can still get at that data. The reason why we don't automatically promote those replicas in that situation is we don't understand the nature of the failure. And you might incur data loss if we were to roll back to the replicas at that point. there might be some data still housed by those vbuckets that haven't started up that wasn't replicated to those replica vbuckets yet. And we don't want to force a rollback by forcing you to use those replicas for writes. Does that make sense? So key system metrics. Couchbase doesn't run in a bubble. There's lots of other software running on these servers, most notably the system kernel, be it Linux or Windows. And these are just as important to monitor as Couchbase metrics. Starting from the very basics, we know that there should be at least 3 beam.smp processes that run on any given Couchbase node. So just have a simple check that counts them. There should be exactly 1 memcached process on any of your data nodes. If we are in 4.0 adding the indexer and query nodes on the data nodes, we know that there will be a projector process that needs to be running, so we can check for that. On the index nodes, there should be exactly 1 indexer process that runs. And if you guys were here for the Cox Automotive talk, you might have seen that they encountered an issue with time being off between their servers. So best practice, check that NTPD is running and verify that your time is at least somewhat in sync. For those that were here for that, now the specific issue that they ran into is they have a very low TTL applied to their documents, something like 4 hours, which happened to be the same amount that their clocks were off between their servers. So the behavior they were seeing was they were replicating from one cluster to another using XDCR. XDCR was in fact replicating the data. We could see the bandwidth utilization as data was being replicated, but the data never showed up on the other cluster. And that's because once it arrived, the other cluster time was off. It saw that that data was already expired and was dutifully deleting that data for them after it arrived on the other cluster. It was doing exactly what it was being asked to do. It just wasn't expected because we don't necessarily check for time. So from the monitoring standpoint, we want to check that NTPD is running and that it is in sync. From a port perspective, it is possible for these processes to be running but not actually bound to anything and therefore not useful. So in addition to checking the processes are there, you will want to make sure that we have a number of ports available. Admin port runs by default on 8091. If you're running SSL for admin connections, it'll be on 18091. The CRUD API, so any sort of basic key value access is going to be exposed on port 11210. Alternatively, you can specify a custom port per bucket. If you do, you'll want to monitor that port instead. And then as far as query goes, if you're using views, port 8092 or the SSL equivalent will need to be monitored. Adding nickel, by default, that runs on 8093. And we have additional ports for the index service on 9101 and 9102. Disk. Can't tell you how often people run out of disk because it's just not monitored. Go ahead.
Going back to the post, what exactly do we need to check on the post?
Just as bound. You just need to run a netstat and grep out that port and make sure that it's being listed on. You can attempt to communicate with it if you like, but generally, as long as it's bound, it's going to be accessible. From a disk point of view, as I said, people run out of disk all the time. Couchbase does not react gracefully when that happens. Couchbase will just crash. You will want to make sure that you have sufficient disk space to accommodate the amount of garbage that you're generating, not to mention just the plain data storage you're asking Couchbase to keep. Common situation is you'll start adding say view indexes, and maybe you didn't have quite the right code that you wanted to apply to that view index, and now your data storage, instead of going up by a factor of 2, maybe goes up by a factor of 10, because maybe you put a loop in your JavaScript and now you're injecting 10 copies of that code into the index. It's happened, and you quickly run out of space. You will want to make sure that you're monitoring that. The bare minimum that I would be comfortable with as an operator is to have a minimum of 20% free space on my drives at any given time. Something like 100% free space, so only 50% utilization would be something that I'd be more comfortable with, but 20% at minimum. And we would expect that this free space would, again, it would oscillate over time. You'd obtain more dead bytes over time, we'll compact them out, but in general, 20% free space minimum. Disk I/O. Again, disk I/O, very often you'll have cyclical workloads, And one of the great things about Couchbase is that we are decoupling your write rate from your available disk I/O. So we will expect to see, especially during these very bursty type workloads, that you will fully saturate your available disk I/O. But in aggregate, we want to see that you're using less than 90% of your available disk I/O, essentially over your peak period. It's okay if this bursts to 100%. As long as your disk write queue doesn't exceed 1 million items, you'll be okay. Couchbase can handle that. But in general, make sure that you have sufficient disk I/O. Only so many options for improving the situation if you are hitting this limit. One would be simply adding more nodes. The other is changing the storage type. Generally, it's going to be easier just to add some additional commodity nodes onto the end as opposed to upgrading your storage across your cluster. From a memory point of view, including buffers and cache, you want to have at least 15% free memory at peak. Couchbase does make heavy use of your page cache, and that's expected. We would much rather be using that memory than just letting it sit idle, not being useful. So make sure you include that in your calculation, but 15% headroom is decent. You should never swap. Couchbase has its own memory management. It handles swapping out data for you to disk. We don't need the OS doing it for us. In fact, you'll get unpredictable results. Your latencies could be crazy if we're having the Linux kernel swapping out from under us. This should always be set to 0. If you're seeing this as anything other than 0, then either you don't have the correct virtual memory tuning parameters. See my amazing presentation on virtual memory tuning parameters from Couchbase Connect 2015 if you want to get those. Or it could mean that you simply have too much data and not enough memory, and you need to add more memory to the system.
Question, so when I install it, so what should do I have to do anything to change the swaps to that space, the memory?
The one parameter that you will definitely need to change is vm.swappiness, sysctl. By default, that's set to 60, which just sets the propensity of the system to use swap. We want to set that to 0.
Why by default it's 0?
By default, it's 60.
Yeah, I know, but why you guys?
Because the Linux kernel developers saw fit to set it to 60. It's not a Couchbase function. We could override it for you, but we don't. We run as the Couchbase user, which doesn't have the ability to set that.
What is the name again? So what is it?
vm.swappiness.
Oh, okay.
And that is on our installation page. It's one of the parameters we tell you to set.
Okay, gotcha. Thanks.
You'll also want to monitor the memcached and beam.smp process memory utilization. Beam.smp, that is our cluster manager. We would expect the memory utilization there to stay steady over time. If it isn't, then you've just found a memory leak. Great for you. But you want to be aware of that so you can address it. Memcached, we would expect that memory utilization for that would grow over time. As you add more data to the system, we're going to be using more memory for memcache. But that should never exceed your Couchbase server quota, at least not by any significant percentage. If you do, then you're encountering some memory fragmentation, most likely. If it's not a memory leak, most likely not a memory leak, most likely memory fragmentation, in which case you either need to address your data model or you need to upgrade to the latest and greatest Couchbase, which includes a new malloc, which has much lower fragmentation properties.
I saw maybe it's an older version, right? So I saw the memory, like this memory cache thing, 90% or something, even more. So it's impact a lot to performance. So
90%
yeah, like
memory utilization?
Yeah, memory. Yeah, probably the memory leak. But around this Windows server, you know, it's not Linux.
So that could be a memory leak if you don't actually have any data stored in the system. If you had data stored in the system, that might be just normal behavior. Couchbase is trying to store that much, and you've told it it can because you set the memory quota to be able to use that much memory. Or it could be fragmentation. It could be that you set your quota to be 100 megs and it's using a gig. That would be fragmentation. And the solution there is either to restart that Couchbase node or to upgrade Couchbase to use the new JE malloc. Network side, total number of active connections. At the very limit, Couchbase can support up to 10,000 connections per node. That's a soft limit, but generally you don't want to exceed it. As an operator, I'd be much more comfortable with something like 2,500 connections per node. These connections, they're going to be persistent, so we're not constantly recreating them, so they're not all that heavyweight, but they do have to be maintained. We are tracking heartbeats across them. There is a CPU cost and an interrupt cost with having those connections. So make sure that there's something sane.
Are those going to be mostly client connections? Or is that
They should be mostly client connections. You also want to check for connections and close awaits. So with the exception of admin connections and, say, stats requests, all other connections to Couchbase will be long-lived persistent connections. If we see connections in a close wait, that means that the connecting application is saying, I want to close this connection. Generally, that means that you have some application server that is probably trying to construct a connection to Couchbase, do a request, and then tear it down for each request. That's a very bad thing. Not only are you generating very heavyweight requests to Couchbase every time you try to instantiate that connection, you're also incurring a whole lot of latency. So that's a good way to let the developers know you got a problem. You need to have a singleton for this instead of trying to instantiate for each request. Because you would expect typically some of these, because of stats requests or just general administration, they won't be zero, but it should be fairly low, probably under 100, 200 connections. And bandwidth utilization, this isn't specific to Couchbase, but in general, whenever you're dealing with objects of different sizes because of inefficiencies in TCP, you would expect to have about 20% of your overall network bandwidth that is just left to slop. It's overhead. So you wouldn't expect to really get more than about 80% of your rated line speed out of a given network card. So if you see that you're approaching that or you're exceeding it, it's time to scale the cluster, give yourself some more bandwidth. On the CPU front, again, not specific to Couchbase, but in general, the percentage of CPU taken up by user should outweigh all of the rest. If you don't see that, that means that your CPU is either being used by system, which means that your context switching is being used by interrupts, it's being used by I/O wait, being used by something other than processing your data, your workload. And that means that there's just too much contention on that server. You need to either add more resources, so add more cores to the server, or you need to scale the server out, scale the cluster out. If you're in a virtualized environment, it's very important that you monitor steal percentage for your CPU. You should always have that at 0. If it's not 0, it means that you have some sort of noisy neighbor. If you're in a local private cloud, you need to talk to whoever manages that environment and say, look, you are oversubscribing my resources, get my Couchbase environment off this oversubscribed environment. If you are out on a public cloud, you probably need to redeploy that Couchbase node into either the same size or a larger size in order to decrease the likelihood that you have some other neighbors stealing your resources. Now, I don't recommend monitoring overall CPU consumption as a metric for how busy your servers are. One of the properties of Beam, so the Erlang VM, is that it has, instead of when it has nothing to do, just doing nothing, it actually puts its scheduler threads into this I/O busy wait state. So essentially it just has, it's doing nothing, it's doing garbage work just to keep the process on the processor, so that in the event some work comes in, that thread is already scheduled, it can start doing work immediately. Because of that, you're very likely to see inflated CPU values on Couchbase. It could be idle, but it's going to appear as if it's doing something. A much better metric to monitor is load, and standard load monitoring logic applies here. So 80% of the cores should be busy at a given time. If you are exceeding that value, it's time to scale. Your server's trying to do too much. Make sense? Cool. And last is just log monitoring. Not much to it. From a monitoring standpoint, 2 logs you want to take a look at. One is the error log, and which will include errors for everything except for XDCR, and XDCR has its own log. Really, when you start out, you want to alert on everything until you understand exactly what these errors mean. And once you understand what is normal for your environment, you can start filtering out those common errors that you don't need to pay attention to. when determining what to do with these errors, two resources that are hugely valuable. One is the admin troubleshooting section of docs.couchbase.com, and the other is the support.couchbase.com website has a knowledge base section that is maintained by our support engineers. So whenever they see the same question 1,000 times, they'll write an article on it. Start there. We have fantastic support, great response times, but a quick search will most likely find the answer for you, so you don't have to wait the hour that it takes for them to get back to you.
So I know there's the Elasticsearch connector for
Yep.
the data. Can that work also with some of the stats?
No. So the Elasticsearch and the Solar connectors, all that does is pipeline data from Couchbase as it's written into those systems. We have no connection for stats. You would still have to monitor that separately.
So we would use like Logstat, like the stat, basically.
You would need to use whatever their stats facilities are. Unless you want to try out CBFT, Couchbase Full Text Search. It'll be released in, I believe, the Watson. You saw it? Awesome stuff. And in which case, you'll be able to get all the stats out of Couchbase. That's it for me. I'm 8 minutes late getting into cocktails, but if anyone's really interested, I'll be sticking around. Happy to answer any questions about any topic beyond monitoring. For the rest of you, thanks for coming out. It was great chatting with you.